All right, we're on the first lesson of rational expressions and equations. So we want to identify what a rational expression is to start. So it's any algebraic expression that can be expressed as the quotient of two polynomials. That's what a rational expression is. So it looks just like a fraction, except the numerator and denominator can be polynomials instead of just numbers. Some examples of rational expressions are, so notice how there are just normal fractions, so that's still considered a rational expression, but really we tend to call any fraction that has variables in it a rational expression. But there are some restrictions on that. The numerator and denominator have to be polynomials. So remember the definition of a polynomial. You can't have, if I have something like this, square root of x plus 2 over x minus 4. Technically, this is not a polynomial, right? Yes, it has a variable in it, but it's not a polynomial. So that means we wouldn't actually call that a rational expression. We can still do some of the same work with it, but we wouldn't call it a rational expression. Non-permissible values. So remember with fractions, you can't divide by 0. So let's take a look at some of these expressions when we substitute a value in for x. So for example here, if we let x be 4, then when we substitute 4 in and simplify, we get 12 over 2, which is 6. That's good. Nothing wrong with that. If we do the same with 2, we get 6 over 0, and then that's not good. Okay, we can't divide by 0, so we say it's undefined. And so basically, this rational expression is defined for all values of x except 2. So a big part of this unit is always checking for non-permissible values, the values of the variable that make it undefined. So some rational expressions are not defined at particular values. In particular, rational expressions are not defined at any value that makes the denominator equal to 0. Since substituting 2 into that expression causes the denominator to be 0, we say it's not defined at x equals 2, and 2 is a non-permissible value. A non-permissible value is any value that makes the denominator equal 0. To find non-permissible values, determine all the values that make the denominator 0. To do that, you're probably going to need to factor. And we're going to be doing a lot of factoring, but it makes it a whole lot easier. Okay, so a lot of times, there's in questions, we might ask you 3 different ways of stating those non-permissible values. So for what values of the variable is each rational expression not defined or undefined? State the non-permissible values and state the restrictions. So when we state the non-permissible values, really you can just list the values. Okay. If it states the restrictions, then you say, okay, the variable is not equal to the values. And sometimes we kind of interchange those. So you'll notice in the solutions to the notes, we might have non-permissible values, x not equal. Really, we're meaning the same thing. So just be aware of that. Okay, so here in chart 1, for each rational expression, determine the non-permissible values. That is, determine the value of x that makes the denominator equal to 0. Okay, and use improper fractions. So first one, you're really finding when 5x equals 0, okay, because really we don't want it to be equal to 0. So that's x cannot equal 0. In terms of stating non-permissible values, that's 0. Stating restrictions, x cannot equal 0. So they're interchangeable, right? Here the denominator, so x plus 3 cannot equal 0, so x cannot equal negative 3. So your non-permissible value is negative 3. X minus 1 cannot equal 0, so x cannot equal 1. Non-permissible value is 1. 4x minus 3 cannot equal 0, So 4x cannot equal 3, x cannot equal 3/4. It's kind of like when we did the solving polynomial functions. We were looking at those factors that made looking for values of x that made each factor 0 to get the x-intercepts. And so it's opposite sign of the constant term, positive 3, divide by the coefficient of x. If it's a binomial like that. So that's 3/4. 3x plus 2 cannot equal 0, so 3x cannot equal negative 2, x cannot equal negative 2/3. Here we have two factors, so we're going to have two non-permissible values, unless the factors were the same. So 6x minus 1, so really x cannot equal 1/6, and x cannot equal negative 5, so your non-permissibles, you just list them. And then the last one has an x out here as a monomial, so that one, x cannot equal 0. And then, of course, this x cannot equal opposite sign of the constant, divide by the coefficient. So 0 and 7/3. All right, by inspection, state the non-permissible values of each rational expression. Okay, so just by looking, now we're not showing any work. Okay, the denominator is 2x squared, so if x is 0, the denominator would be 0. So anytime it's a monomial with a variable, it's going to be 0. Here it's a monomial, two different variables. So here, x, I'm going to show it as more in the restriction form because there are two variables. Okay. Next one, opposite sign of the constant, negative 4. Opposite sign of the constant, 5. Then the next one, opposite sign of the constant is negative 3, divide by the coefficient on the variable. Here there's two of them. So opposite sign of the constant in the first is 2/3. And then in the next one, negative 1/5. And then here, this is a monomial. So that's 0. And opposite sign of the constant, divide by coefficient is 6. So this chart said non-permissible values, so you can just list them. If it said restrictions, then we would go x not equal or y not equal, etc. Most of the time, this is what we're actually going to end up showing because it's not going to specifically ask for the non-permissible values when you are simplifying an expression. So we're going to just list those values on the side. Okay, so then here, write a rational expression with the following non-permissible values. So it doesn't really matter what you have in the numerator. You can have anything. So notice how this is really written as restrictions. So maybe we have 3x up top. Okay. Oh, actually, in this case, if I had 3x up top and say 5x in the denominator, that has a restriction of 0, and that's fine. Okay. The x's do divide out. It would give you 3/5, but you always want to look at the original. So that's okay, like that. Then I'll just keep the 3x. It should be t now. And t can't be 5. So remember that the opposite sign goes in with as the constant term in that bracket or in that denominator. Here, if it's a fraction, this will be y, then you need to have the constant term being the opposite sign, so positive 3, and the coefficient of y will be the denominator. Oh, sorry. And then two non-permissible values means we're going to have two brackets, two factors in the denominator. So I'll just keep 3x, I guess. So we're going to have two factors. These are just integers, so it's going to be the opposite sign of each one. Okay. Here we have 4, so there's going to be 4 factors. Anytime you have a non-permissible value of 0, then that's in a monomial. So I need to use m's here. So I'm just going to have m out front. You could have 3m, 10m, something m, but it has to be a factor of just m. And then 2 brackets. This one, opposite sign of the constant. This one's a fraction, so that's going to be +1, and this is going to be 3m. Okay, so that's working backwards. Most of the time we don't work backwards too much. Mostly it's coming up with the non-permissible values. Okay, so now we're going to get into simplifying. So fractions come in many equivalent forms. You know, with just numbers, 10 over 20 is the same as 4 over 8, is the same as 3 over 6. Reduced to lowest terms is 1/2. So 1/2 is in simplest form. You keep dividing by any common factors. So that's what we're going to have to do with rational expressions. Here's a rational expression with a bunch of variables, but they're monomials. So really, you can express it back from Math 9. You learned some of your power rules. In any case here, we're not going to show it with negative exponents. We're just going to reduce the coefficients to 4/3, basically dividing by 6. Then x squared is common to both, so we have x cubed in the denominator, and y is common to both, so we have y squared in the numerator. Okay, in terms of non-permissible values, we look back to the beginning. So our restrictions are x cannot equal 0 and y cannot equal 0. Here we don't see a y. That's why we always have to go to the beginning, because you might be asked to substitute values in for x and y, and it has to work no matter what form the rational expression is in, whether it's in simplest form or not. Okay, so question 4. Each row contains a rational expression that's not simplified. Express it in factored form and simplified. First one's been done for you. So factor the numerator, factor the denominator. Take a look here, your non-permissible values. We're going to show them as restrictions. Okay, so that's going to be x cannot equal 3 over 2 and positive 2. And then simplifying, that's a common factor with that. Take a look at the brackets. That's the first thing. And then monomials. All right, so you're left with 5 over 2x minus 3. You always state your non-permissibles from this step, okay? Because you'll miss one if you do it here. Okay, next one, trinomials. That's why you have to be good at factoring for this unit. So 2 numbers that multiply to -6 add to -2 are -3 and positive 2. 2 numbers that multiply to 3 add to -4 would be x minus 3, x minus 1. Your non-permissibles or restrictions are positive 1 and positive 3. And notice how these divide out. So you're left with x plus 2 over x minus 1. You don't have to show the brackets anymore. Next one, nothing to factor. In the denominator, there's an x that's common. You're left with x plus 3. Restrictions. Okay, there's a monomial factor, so x can't be 0 or -3. And then brackets don't divide out, but x goes into x squared and leaves you with x. So you're left with 5x over x plus 4. Okay. Next one, common factor is 3. And difference of squares in the denominator. So 2x plus 1, 2x minus 1. So your restrictions, -1/2 and positive 1/2. You can show that as plus or minus 1/2. Okay, that tells you there's one that's a half and one that's -1/2. Then dividing out, And you're left with 3 over 2x plus 1. If you have a negative leading coefficient in any of these, factor it out. So in the next one, negative 2x is common. You're left with 3x plus 2. Non-simple trinomial, so two numbers that multiply to negative 18 and add to negative 7, which would be negative 9 and 2. So we want 3x and x. Negative 9 would mean we need a negative 3 there, plus 2. Okay. Restrictions would be negative 2/3 and positive 3. And notice that the brackets divide out. We just show you what's left. Okay, again, non-simple trinomial in the numerator. Denominator is just a common factor of 4x squared. Okay. And so we need two numbers that multiply to negative 30 and add to 1. So that's 6 and negative 5. So we'll have 2x and x. 6 would have to make that 3 and negative 5. Oftentimes it will end up being that you can divide something out. So that's why you can always take a look. Is 2x minus 5 a factor? Restrictions. Again, there's a monomial here, so that means 0. And opposite sign, divide by the coefficient. Left with x plus 3 over 4x squared. Okay, so lots of factoring. So it says write 3 steps on how to convert a non-simplified into its equivalent simplified. So first, factor the numerator and denominator completely. State your restrictions from the factored denominator. And then divide out any common factors. Numerator and denominator. Okay. We don't end up expanding back. We just leave the factors in the numerator and denominator. Okay. So simplify each of the following and state the values for x not defined. So here, this is just 2 monomials. So we're going to divide 6 goes into itself once, into 48 8 times. So that's going to be, so a negative 8 down here. M goes into m cubed, m squared times. And n squared goes into n to the 5th, n cubed times. Back up here, it's really already factored. So m cannot equal 0 and n cannot equal 0. There's no adding and subtracting in it, so it's going to be just zeros. Next one, common factor, numerator and denominator. Okay, so here x is not equal to 2, and then those divide out. Okay, oftentimes actually we wait and show the non-permissible or restrictions right next to your simplified form. Nothing to factor here. It's a trinomial, so x plus 4 is x minus 3. So if you show your work, you can wait and state the restrictions in the last step, because you can go back and look at it. Those divide out. That's like having brackets around the whole numerator, right? So those divide out, left with 1 over x plus 4. And your restrictions are negative 4 and positive 3. You have to look back at that factored statement before simplifying. Next one's 2 is common. Simple trinomial. Two numbers that multiply to -8 add to -2 would be -4 and +2. And then let's divide out. So we're left with 2 over x plus 2. And x cannot be equal to 4 or -2 from this statement. Notice how here you cannot divide out this 2. So this does not end up being 1 over x. So sometimes students will see this and they'll go, oh, I'll just divide that out. Okay, can't do that because 2 is not a factor of the denominator. It's x plus 2 there, so it's a term in the denominator. Next one is non-simple trinomial with x's and y's. So there'll be 2x and x, something y, and difference of squares in the denominator. Okay, so two numbers that multiply to 10, add to 7 are 5 and 2. So this is going to be plus y plus 5y. And then square root of each term. One has a plus, one has a minus. Okay, those divide out. And you don't have to show the brackets any longer because it's just one factor in each. And then your restrictions, this one's a little bit weird because it's got x's and y's. So it's really 2x cannot equal -5y over 2. Sorry, x cannot equal -5y over 2. And similarly, you can solve for y from that. So that's a little bit different with x's and y's. Can't really say one particular number. Next one's 3 is common. X plus 5 over 6x is common. X plus 2. Okay. Just checking. Not much. So all there is here, the brackets aren't the same. So 3 goes into itself once, into 6 twice. So now we leave it as x plus 5 over 2x bracket x plus 2. We go back to this step. X cannot equal 0 or -2. There's a factor of x, and the restriction is 0. Okay. And the last 3, common factor in the numerator, denominator, non-simple trinomial, multiply to -6, add to 5, so that's going to be 6 and -1. Okay, and then x plus 2's divide out, so you're left with 5x over 3x minus 1, and x cannot equal, you go back to the factored step, 1/3 and -2. Next one, notice that it is not in descending order of degree, but it is a difference of squares. So I'm going to factor it just as is for right now. Non-simple trinomial, two numbers that multiply to -42, add to 1, so 7 and -6. Okay, notice how this is 3 minus x and this is x minus 3. They're close, but they're not exactly the same. So what you want to do is, I'm going to rearrange my factors to be in the proper order. So that's x plus 3 when I rearrange that. This would be -x plus 3. Copy out the denominator. And now I can see that I don't like having a negative as my leading coefficient. So I'm going to factor out that -1 to the beginning. You can even put a 1 if you need to. When I factor out a -1 from here, it's going to leave me with x minus 3. And those divide out. So then, I can show this as negative bracket x plus 3 over 2x plus 7, or factor in, you can expand in the negative. Normally we leave it factored, but you can do it into that, either one of those. And remember, x cannot equal negative 7/3 and positive 3. And then the last one, non-simple trinomial again. Multiply to 12, add to 7, so 4 and 3. Now the next one is a factor by grouping. So I'm going to show that on the side here. That'll be x squared factors to 2x plus 3, and then minus 4 factors to 2x plus 3. So then I'll factor that out. So 2x plus 3 times x squared minus 4. All right. Notice on that, I can divide these out, but I haven't finished factoring this yet. So I can do part of it, but now this ends up being x plus 2 times x minus 2. And now I can put brackets around my numerator. Those divide out, and I'm left with 1 over x minus 2. My restrictions, I need to go back to my factored form, so negative 3 over 2. And actually, I need to look at this factored form here, plus or minus 2. So really what, I kind of ran out of space. If you could do all your factoring in one step, that would be awesome.